Hello everyone, welcome to the third session, as Jane said. Our first speakers are going to be John Herlihy and Peter Galant. They're going to be speaking together. John Herlihy is Director of the Water Quality and Environmental Management for the Aquarian Water Company, which is a public water supply company serving a population of 580,000 people in 36 towns across Connecticut. And he has over 30 years of experience in drinking water quality and environmental management matters. Mr. Herlihy is also the Vice Chairman of the Connecticut section of the American Water Association. His colleague Peter Galant will be speaking with him. He is the Vice President with Tig and Bond and the leader of their Water Technical Practice Group. He has over 20 years of experience in water supply planning, design, construction, and Peter Galant is a past president of the Connecticut Water Works Association and a member of the Water Resource Committees of Connecticut, of the Connecticut section of the American Water Works Association. Please welcome both Peter Galant and John Herlihy.
Good afternoon. Thank you all for having us here. It's been great being here since Friday noon and soaking up all the knowledge on these issues, both local, nationwide, and international. It's been a terrific learning experience for me, and I appreciate the opportunity to be here. Peter and I are going to talk about public water supply perspective on water scarcity and conflict, and that is primarily for us in Connecticut a matter of streamflow and streamflow regulations and the impact on the amount of water that's available for water supply. It's an outline of the journey we're going to take you on over the next 30 minutes. I'm going to tell you a little bit about Aquarian Water Company in the first bullet, and then talk to you about the business of water supply. What's it all about? Peter's going to cover water supply planning and the impacts of streamflow regulations on our ability to supply water, and then the important considerations for setting these streamflow regs. So this talk kind of goes hand in hand with Lee Dunbar's talk from this morning, and then we'll wrap it up with some conclusions. There are three primary components to a water company or a public water supply system, and that's the owners, the customers, and the employees. And the customers are the reason that a public water supply exists in the first place. Ownership can be either public or private. So the city of Groton, for example, nearby, is an example of municipal public ownership. There's a Southeastern Connecticut Regional Water Authority, and there's also a regional water authority that supplies water to metropolitan New Haven, South Central Regional Water Authority. In Hartford, you have the Metropolitan District Commission. So those are quasi municipal, publicly owned public water systems. Aquarion is privately held. It's owned by investors. And the company was founded by investors in 1857, so a little before the Civil War. And the company was found because there was a group of investors that had a problem that they needed to solve. They used warehouses for their businesses where they stored products that they sold, and those warehouses would catch fire and burn to the ground, and all the products inside would burn also. And they determined, well, you can't really sustain a business under these conditions. We have a problem, we need to solve it. So they got together, they identified what the cause of the problem was, they identified solutions, they selected a solution, came up with the financing, and implemented it. At that time, there was no public water supply. There were a bunch of small private wells, and so the solution they chose was to design and build a public water supply system for fire protection purposes. So they came up with the financing, they purchased land, they hired engineering expertise, built a dam, flooded that land, creating a reservoir, and then put the piping system in place down to where their warehouses were, and their plan succeeded. They were able to eliminate, control the fire problem, and soon other companies were attracted to the location of this water supply. And soon industries came. They said, well, we can use that water in making our products, not just for fire protection. And so the city grew, and at some point in time, the water was used for public consumption, not just fire protection. And the company's been in continuous operation for 152 years, so they must have been doing something right. Customers. Aquarion Water Company supplies about close to 600,000 people in Connecticut. I think the current population in Connecticut is 3.5 million. And we supply those people through 180,000 service connections. So that's a connection between our distribution system and their premise. They're a house, a factory, a hospital, etc. We serve water in 36 communities around the state, 6 out of our 8 counties, and through 23 public water supply systems. So a public water supply system has a source of supply, in most cases treatment, and then a distribution system. Some of our public water systems supply individual towns. Here in the Simsbury area, we've got 3 towns supplied by one system. Down here, our Mystic system serves a part of Groton and a part of Stonington. Our biggest systems are down here in Fairfield County. The Bridgeport system supplies about 10 towns. And then there's a regional pipeline which takes water all the way down to Stamford and into Greenwich. So we have one large reservoir in Weston and Reading that is really the backbone of water supply for this whole area here. And we do all that work with 260 employees. So we have environmental scientists, we have engineers, we have finance and accounting people, human resources, customer service people, operators. Water utilities are very infrastructure intensive. We own 29 dams, 43 treatment plants, almost 3,000 miles of pipe around the state. Our sources of supply include 34 well fields, 9 reservoir systems, and we also have 5 interconnections to other public water systems. On the average day, we deliver about 85 million gallons of water. On a peak day, as much as 125 million gallons of water. And most of the water that we deliver is surface water from the reservoirs down here in the Fairfield County area. So what's a public water supply all about? Well, you can find that out by looking at its mission. And this is a mission that is fairly typical of most public water suppliers. To provide a reliable supply of safe, high-quality drinking water, sufficient to meet customer needs at a reasonable cost. So reliable, because when you get up in the morning, you expect to be able to take a shower 7 days a week. No interruptions. When the fire company responds to a fire, hooks up to a hydrant, they expect to have sufficient flow of water at adequate pressure to get a lot of water on the fire. Industries, they operate 3 shifts around the clock using water to make their product. It's got to be available at all times, at the right quality, and at the right pressure. Safe, because people drink it. High quality, because commerce and industry need adequate quality in making their products. Reasonable cost. Customers have to pay for this water, for the investment in the infrastructure and for the cost of delivering it. But I think the key part of the mission that we're here to talk about today is the third line, sufficient to meet customer needs. What is sufficient? I think that's what we've talked a lot about today. Who determines what sufficient is? I think for the last 152 years, it's been primarily the customers that have determined what sufficient is. As individuals, how much water they want to use. Do they want to take 40-minute showers? Do they want to water their lawns in the rain? Okay. In industry, do they do a good job of controlling leaks in their plumbing systems? As long as they're able to afford to pay for the water, they get it. I think that's the crux of what we're going to talk about today. The benefits of public water supply include public health protection. Public water supply systems have been one of the key reasons that the country has been able to thrive and prosper over the last 100 years. Safe drinking water is not something that people have had to worry about, and so you haven't had mass epidemics in the big cities. Fire protection I've already covered. Support for the economy, jobs. And these three things combined produce a quality of life that's second to none. We are employing people and we are operating facilities. We have positive and negative impacts on the environment. Water. There are water discharges from facilities. And we dam streams and we withdraw water from reservoirs to put it into our water supply system. Buildings have to be heated, so there are discharges to the air. The people produce solid waste from these buildings. We store treatment chemicals and we store fuels to heat those buildings and to fuel our vehicles. So all of that needs to be managed. But on the positive side, we manage to minimize pollution activities on the watersheds that surround our reservoirs. We manage the forests on the land that we own. So there are positive and negative impacts. The water supply industry is very heavily regulated. Water quality and quantity are regulated by the Department of Public Health, and there are approximately 100 parameters, quality-related parameters, that are subject to regulation by EPA and the State Health Department. DEP regulates us on withdrawals and release of water from our dams to the streams, and also the discharges that I mentioned in the previous slide. Department of Public Utility Control is our financial regulator. So they determine the rates that we can charge our customers, and they also make sure that we are providing good service to these customers. And I'm happy to report that Aquarion Water Company, for the second time in a row, has won the DPUC's scorecard award as the best service provider in Connecticut, not just among water utilities, but across all the utilities that DPUC regulates. So this is a diagram of a typical water system. We have a source of supply, transmission piping, a treatment facility, we store water, and then this is the distribution system and the customers. The owners buy the land that's under this water and some of the land that's on the watershed surrounding it. They pay to put up the dam. They pay for all these pipelines. The treatment plants, tens of millions of dollars. The storage tanks, the investment. The customers create the demand and the reason for that investment in the first place. The company operates the system. So we have employees, we have environmental scientists that manage land use activity both on the land we own and monitor the activity on the land that we don't own in order to minimize contamination of the waters that flow into this reservoir. We have other environmental scientists that are in charge of monitoring water quality in these streams, in the reservoir, the raw water, the water leaving the treatment plant, and in the distribution system and at the customer's premise. We have engineers that design these facilities. How big does this reservoir need to be? The dam, the size of the pipeline. They do the water supply planning. Like I mentioned before, we have finance people, we have customer service people that deal with customers' questions and concerns. We have pretty good sized information technology department. Computers are what support the entire range of our operation, including operating these treatment plants, keeping track of the billing and the money, the water quality data, models, etc. For a little bit of a national perspective, AWWA, American Water Works Association, is the industry organization at the national level. And on an annual basis, they conduct a state of the industry report, and they ask water system managers, what are your top 5 concerns? And get back about 25 of them, and the top 5, look what number 1 is, source water. And the biggest part of that source water concern is quantity. There is some concern about quality, but most of the concern is about quantity. And that breaks down into adequacy of supply, which is impacted by climate, by drought, that type of thing. And the other is increasing demand. And where you have those two things coming together in the southwest and the southeast with more and more people moving there, and water supplies having difficulty, especially in drought in terms of quantity, that's a significant challenge. And then when you throw climate change in on top of that, you can understand why this item is the number 1 concern. Also concerned about infrastructure. Company's 150 years old. Pipes have a design life. Most of this pipe was put in the ground not on an even amount of investment year after year, but in peaks. So a lot of investment in the late 1800s, a lot of pipe in the ground in the 1920s, and a lot of pipe just after World War II when you had the population explosion and the baby boom crowd coming on board. So this infrastructure needs to be replaced, not just pipelines, but the treatment plants, pumping stations, tanks. Regulatory. The regulations have not stopped since the Safe Drinking Water Act, 1974. The regulations that EPA is coming out with now, recently a groundwater rule. Most of the focus has been on surface water quality. Now they're switching to groundwater quality. They're redoing the coliform rule, coliform bacteria, quality of the water. And they're also, the emphasis in Washington is now switching from quality leaving the treatment plant to quality in the distribution system. So there's concern about what will these regulations look like. One of the things that we always push for is making sure that in these regulations, our customers have to pay for the cost of implementing these regulations, making sure that they obtain a real health risk reduction benefit from the money that they're going to have to pay. And the same needs to be true on the environmental side. Our customers are going to pay for the cost of implementing these new streamflow regs. We want to make sure that there's a real benefit that is being obtained. Number 4 is one that a lot of you should be interested in. Workforce. The baby boom generation is at retirement in some cases, on the front end of the wave, and nearing retirement, say in the next 10 years. So there are a lot of people that are going to be leaving the industry in those categories that I mentioned before: engineering, science, finance, etc. And we're also hearing that fewer students are choosing to study math and science than when I went to school. So that's good news for those of you that are studying math and science. You'll be in very high demand. But for us in the industry now, it's a challenge. We have to figure out how to attract the smaller numbers into the field. And then business factors has to do with the financing and how we're going to pay for the regulations, the infrastructure, and source water issues. Peter is now going to talk to you about the technical aspects for our topic. Thank you.
Thanks, John. So John's given an overview of Connecticut, Aquarion Water Company of Connecticut, and the business of water supply. I'm going to get into how water supply planning is done in Connecticut, and then building on the presentation of Lee this morning, things that we need to think about when setting new streamflow regs, putting more water in the streams, what the impacts can be on public water supply, and what we need to think about in that balancing act that Lee was talking about. And I think I'll go very quickly, looking at my watch, very quickly through the water supply planning in Connecticut, and maybe pop. All water companies of over 1,000 customers are required to do 50-year water supply plans. That's demand projections for 50 years, and look at where the supply will come to meet those demands. And those projections are done as part of a document called the Water Supply Plan, and are reviewed and approved by the Department of Public Health, Environmental Protection, and Public Utility Control. And those plans also include drought plans and water conservation plans. There's Aquarion's plan. It's a pretty significant one. There's a lot of stuff in here. Part of that is margin of safety. That's just simply the ratio of supply to demand. So margin of safety of 1, supply equals demand. Greater than 1, you've got more supply than demand, and less than 1, you don't have enough supply to meet demand. That's looked at on an average day versus safe yield, the ability of the supply to provide water during a severe drought, and a maximum day compared to the capacity of the supply, the size of a pump or the capacity of the treatment plant. And there's no set rule for what an adequate margin of safety is, but in general, the Department of Public Health looks to achieve a target of 15%. And this is an example of an analysis done for one of Aquarion systems, and you can see the margin of safety when it went into deficit. There are plans and specific sources identified for solving that deficit and for adding supply to the system to meet customers' demand. There are drought plans that are in Connecticut. There are 4-phase drought plans. The phases are advisory, watch, warning, alert. Systems have triggers based on their risk as to when to go into each of those phases, and have demand reduction actions associated with those phases too, to try to reduce demand and avoid the catastrophe of running out of water. Conservation plans, there's a demand management and supply management section of conservation and normal day-to-day operations, which conservation is different than drought response. Conservation is day-to-day. Drought response is in response to a short-term situation. Lee talked about the 2 components of the proposed streamflow regulations in Connecticut, the reservoir release rule and the ground, which requires an amount of water from the reservoirs to be released into the river every day, and the groundwater withdrawal rule, which sets limits on how much can be withdrawn every day. And I'm going to look at, show you some analysis of the impact of a rule on Aquarion system. This is not the latest version of DEP's rule, but a previous version. I'm doing it not to be critical of the rule, but more just to illustrate the types of impacts that a streamflow regulation may have on a water system that needs to be considered in setting these regs, and DEP has listened to this input in revising their regulations. There are a lot of potential impacts, and I'll touch on each of them briefly. This looks at reservoir, that margin of safety, the ratio of supply to demand that I spoke of, in 5 of the Aquarion systems. Under the current release requirements, each of these systems have more supply than demand, albeit marginal in the Mystic area. Under the previously proposed rule, that 3 of those systems, including the largest one in the greater Bridgeport area, would go from a surplus of almost 50% to a deficit of supply. And what that would mean is moratoriums on new service connections, so no new development in town. It would mean risk of running out of water. If we're less than 1, that means that we, in a drought, could run out of water. And it also means we need to invest in finding new supplies to remedy that situation. So we're going to need to develop new sources of supply. Likewise, on the groundwater side, this was a look at 20 well fields, at how they might be impacted by a proposed rule. And in this case, 15 of the 20 would have their withdrawal capacities limited by setting the Streamflow reg the way it was proposed, and some of them severely limited. And that means the same 3 things as the loss of reservoir supply did. Increased risk, primarily. This was a model we prepared of one of the reservoirs in the Bridgeport system. It's a mass balance model from the 1920s to early 2008. We used historical inflows, current demands, and assessed it against determined reservoir levels based on the red line, which is the existing release rule, and the blue line was this alternative rule. And you can see, as you expect, you're putting more water in the river, there's less in the reservoir, so it draws down quite a bit further. And in several cases, this reservoir would have actually failed and run out of water completely. But consistently, it's lower than when you're putting more in the river, and that has some potential impacts. It has water quality impacts from warmer water, more algae, more potential metals, and taste and odor potential. And reservoir ecology, this is an interesting one. We had one case where, complying with the rule, we emptied the reservoir. Mark showed some pictures of empty reservoirs, and actually created ecological problems in the reservoir itself by emptying it. But all that means, if you saw the drought triggers, we're going to have more frequent droughts and of longer duration. This is the results of that model showed. Under the current release scenario, we would have been in a drought advisory in roughly 6 times over that 80-year period, or once every 14 or 15 years. Under the revised proposal, it would be 37 times, or almost every other year. And the maximum duration would go from 6 months to several years. And there's a significant cost as well. In the case of Aquarion, in the previous draft rule, we estimated about $150 million cost for compliance. To put that in some perspective, Aquarion invests roughly $30 to $40 million a year in its infrastructure. So it's about 5 years of its capital spend. Or if this were to be put on top of its normal capital spend, about a 20% rate increase for its customers. So what are the things that we need to think about? With all that in mind, what things do we need to think about? I don't have all the answers here, really, just a lot of questions when setting new regulations. What is an acceptable frequency for drought and duration for drought? As a water supplier in the past, I felt that I failed the customer when we went into drought, and I think the customers feel that way too. I've been to enough of these conferences to understand that that is not the case, that we have to accept a certain level of drought and drought frequency. But what is acceptable? I personally think it's somewhere in between the once every 2 years and once every 15 years. But how do we make that decision? I really don't know. Climate change, all the analysis that we've done to assess the yield of our supplies and the requirement for flow in the river have been based on statistical analysis of previous flows. Those flow patterns are going to change in the future. What impact will a regulation have on development, and how do we control it? Obviously, less water is going to limit development, but so we need to coordinate that with local plans of development so that we're not stuck with water companies in the middle, not having enough water, and developers still buying the land and getting their approvals to build on it, and turning to the water company who doesn't have enough land. So we need to do it smart, I guess smart growth. But that needs to be built into the process of these new regulations. Can we prioritize uses? We heard about having a right for water for fire protection and drinking uses, but that we don't include lawn watering and pool filling in that. That sounds good, but as a water company, we meet our customers' demand. So if we're going to prioritize those uses, how do we do that? I think the best way is by regulating the uses. Low-flow toilets was a great example of a way to reduce demand on water. And that's the next question. How do we get people to conserve? Demand management needs to be a part of the solution. It's not the full solution. We can't make up that whole lost supply by controlling demand, but it needs to be part of the solution. I haven't touched on it yet, but in Connecticut we have a restriction on what water supplies can be used as drinking water sources. Class A waters, the highest quality waters in the state. Those happen to be the most ecologically sensitive and valued as well. Do we need to go to lower quality water, take more risk on water quality, and rely more on treatment so that we can preserve the higher quality waters for the ecology? That scares me a little bit. Affordability we've talked about. When we're done, before we set a regulation, we need to make sure there's enough left for the public needs, because we don't want to be in the position of setting the regulation and then finding out. And we have time to do it right and make sure that that doesn't happen. How do we communicate the ecological benefits? A lot of what Mark said this morning resonated with me on this communication piece, because it's going to be important in order to make that balancing act, to communicate the benefits as well as the costs. The cost being money, as well as slower development, increased drought restrictions. And with that, I'll turn it back to John. We have a minute left. A negative minute, John.
That's it? Negative minute?
Talk
Okay.
faster than the speed of light.
All right, I'll just talk about the first bullet. The most important thing is to participate in this debate, and debate is a form of conflict. Physical conflict you want to avoid, but there's nothing wrong with conflict in ideas. That's how we learn. That's how we come to the best decisions. That's how we see beyond, we see the whole pie, we see beyond the slice of the pie that we're most familiar with. So I would encourage conflict in ideas and learning from each other and coming to a realization, you know what, you're right about that, and I'm going to change my thinking and my behavior from now on, that type of thing. Where are we? Q&A.